Good morning, friends. Today we are going to do the lab exercise 2 from the associate degree program thermodynamics, and this experiment is also similar with the BS program. So this is the energy balance for open system. Thermodynamics means we need to know the law of conservation of energy, law of conservation of mass, and law of conservation of moment. In this experiment, we are going to learn the law of conservation of energy and law of conservation of mass. Means it is a first law of thermodynamics and the continuity equation. So objectives of the experiment I will explain now how to write the objectives. Now first objective is a law of conservation of mass, means how much air is coming inside this. We need to find the mass of the air. So our first objective is to find the mass of the air. Then next objective is how we can find the mass of air to apply characteristic gas equation, ideal gas equation and characteristic gas equation, ideal gas or characteristic gas. We are going to use the air as a gas, so it is a characteristic gas equation and we know the R value. So instead of, better to call a characteristic gas equation. Number 3, to apply the first law of thermodynamics. What is first law of thermodynamics? To find the energy, to find all input and output energies, energy system for the system. Number 4, to find input and output means what is the ratio in output by input is efficiency, to find all efficiencies of component, all efficiencies of component. So these are the objectives. First, I will explain the each and every component of the thermodynamic system. The compressor. So this is the electric motor which is used to run this compressor. This compressor is a vent type of compressor. So we have two types of compressor, reciprocating and rotary. And so this comes under rotary. It is not a reciprocating. So this is a inlet. The inlet air comes and the outlet air, high pressure energy goes out. So that's why it is insulated, because it is high pressure and high temperature, it is insulated. Okay, so this compressor is run by the electric motor, and the electric motor is run by this power, and the electric power consumption is measured from this number 4 power wattmeter. Number 5 is a mass used to measure the torque, and we can remove this cover and we can measure the speed here. So N, we can measure the revolution and we can measure the torque by measuring mass, and there is a length here. The arm is connected to the electric motor, and when we start the power switch on and electric motor on, this electric motor starts, we can measure the speed. So when electric motor passes, there is a jerk. Electric motor will make a jerk, and that jerk we can measure by using the mass spring balance, and that length of the arm into the mass will get a torque. That mass is converted into Newton. The force is equal to mg, so we'll get Newton, and length of arm is given to you 0.2 meter. So we know length and we know measure, we can measure the torque. I will explain this in detail later on. This is a thermocouple. There are two thermocouples. One is for inlet and one is for outlet. It is used measure here T1 and T2. Here we can measure the power, electric power, WEL. Here we measure V in. Here we measure P2. Here we measure P1. And here we measure mass. Of all, we need to write our observations. So our observations are given to you. So this, as it is, you need to write this. It is a given data to you and you need to write in the observations. The length of the torque arm is 0.2. Compressor swept volume is given to you. What is meant by swept volume? The swept volume is the capacity of the compressor. So what is the capacity of compressor? If you buy any car, so engine capacity is given. So how much, if it is a petrol car, how much petrol and air comes inside the cylinder? What is the capacity? So if you take the example of like a Jeep Liberty or anything, so it is written 3.7 liter. So what is the meaning of this? 3700 centimeter cube. Means this is the volume size of the engine. So same here, the compressor swept volume. This is the size. Here we need to convert this in meter cube. this is a volume. So this is a given to you because compressor, this is a capacity of the compressor, it is given to you. And specific heat of the air is constant, R is constant. So Cp minus Cv is equal to R. I can find out Cv also by this formula. Any two value will be given to you. We can find out third value. This is an important formula. And remember another formula, Cp by Cv is equal to gamma. We will explain this later on. So this is the observation given to you and you need to write from your lab manual as a given data. Now observation table. So observation table. How to prepare the observation table? So first I need to measure the atmospheric pressure and temperature. And here the atmospheric pressure is 1.01325 bar. So no need, we can cancel this and we can write 0.01 bar, and it is nothing but 1.01 into 10 to the power 5 Newton per meter square. Remember, here we need a primary SI unit, not a derived unit or not a secondary unit, so we need to write. So what is the atmospheric temperature? Generally, nowadays, it is at 24 degrees centigrade, okay? So it should be a Kelvin, 24 degrees centigrade plus 273, so it will become a Kelvin and it is 297 Kelvin. So this atmospheric air comes inside, so here PATM, TATM. Then this atmospheric air comes inside the cylinder. So what I have to measure? I have to measure a V in. So I will write the V in. So first ATM, PATM, TATM. Then second, third V in, volume flow rate. It is given you in liter per minute. Then this is a wall, control wall. Here I can adjust the pressure P1 and P2 in the ratio, and I can write the pressure P1. Okay, so this should be in observation table, and then I need to measure the temperature T1 here and T2 here. So I need to write another column. This is 3, 4, 5, 6. That is a temperature T1 and temperature T2. So T1 becomes same. There is no change. So it is 297 Kelvin. I need to measure T2, or it may be changed after sometimes as room become hot, then it will be changed by 0.5 degrees. So no worry. T2 we need to measure. Then electric consumption we need to measure 7 WEL you need to measure, and last a spring balance M is equal to we need to measure. So this is the observation table. So how many rows you have to make? 2 rows for symbols and units and particulars, and another 7, 8 rows for this. Now once your observation table is ready, now we will record the readings, and we found the readings. These are the readings, and now we will do the calculation for the reading number 2. This observation table, what is the unit available in the on the machine, I wrote as it is. So then I will convert all primary SI unit in a sample calculation, and I will write the calculation table. Sample calculation. So first I need to convert the atmospheric pressure. PATM is equal to 1.01325 bar. I will consider only I will consider all digits, no problem. 1.01325 bar means 10 to the power 5 Pascal Newton per meter square. So this is called primary SI unit. Then atmospheric temperature, it is a 24 degree centigrade. So 297 Kelvin, as I explained before also. Number 2, the temperature at inlet of the air is equal to T1. T1 is equal to, it is assumed as T atmospheric. Why it is assumed, I explained already, or I can explain here. The atmospheric air comes inside, and here there is no energy added in the machine. So temperature of the air, as it is isothermal process, the temperature remains constant up to atmospheric to point number 1. Here it is a state point 1, P1 and T1. Okay, so all the pressure here is P1 and T1, and volume is V1. Pressure at inlet of compressor is P1, and P1 it is a gauge pressure. Whatever we measured is a gauge pressure. So we need to find absolute. So it is here P gauge, P atmospheric plus or minus P gauge. P1 is equal to, so if no need to write absolute. If I wrote 1, it is mean absolute. So atmospheric pressure is 1.1325 into 10 to the power 5, and here we will consider minus. Why minus? Because this is the inlet and here the suction is created, and whatever the pressure shown here is a suction pressure. So here we record it as a minus minus minus. So we need to minus this 0.15 minus, for second reading the pressure is minus 1.5 bar, means 10 to the power 5 Pascal. 0.86325 into 10 to the power 5 Newton per meter. Fourth, then P2, pressure at outlet of compressor. I need to transfer this value in the calculation table. So it is a P2. P2 is equal to, again this is a absolute. I need a absolute. So P atmospheric plus or minus P gauge, and here I need to select the plus sign because it is more than atmospheric and it is a higher side pressure. So it is 1.01325 into 10 to the power 5 plus the double of this 0.3 into 10 to the power 5. So here you will get 1.31325 into 10 to the power 5 Newton per meter square. So pressure at outlet of compressor. Then volume flow rate number 5. It is given V in. So how much V in? 330 liter per minute. So this is not a SI unit, so I need to convert it. 330 liter means 10 to the power minus 3 meter cube. I am not explaining you divide or multiply. No, replace. 1 liter is equal to 10 to the power minus 3 meter cube. So replace 1 liter. 1 minute. 1 minute is equal to 60 seconds. So replace this. So here I replace this liter, and what is meaning? Divided by minute. Minute means 60 seconds. So here I will get Vn is equal to 5.5 into 10 to the power minus 3 meter cube per second. Don't memorize divide or multiply. In exam you will confuse. Number 6, speed of compressor or electric motor. So N is equal to 1658 RPM, revolution per minute. 1658 divided by 60 revolution per second, RPS, and it is 27.633 RPS. Now next, spring balance 7. So I will calculate the force. Spring balance force, because I measured mass. So force is equal to mass into gravity, 1.1 kilogram. 1.1 into 9.81 is equal to this kilogram meter per second square. So remember, kilogram meter per second square is nothing but a Newton. Okay, and this is 10.791 Newton. And electric power consumption, no need to convert, and it is same. WEL is equal to 0.92 kilowatt, 0.920 watt. So this is first part of the calculation, and now our calculation, there are 3 steps, 1, 2, 3. First I need to find mass as per objective, mass of year, m year. Then I need to find input and output, and then I need to find third part is efficiencies. Okay, so we'll see one by one how we can calculate. So as I told you, the atmospheric year comes inside a volume flow meter. Then it goes pressure gauge, where it goes to the compressor, going inside, and the high pressure here will come out here. So here PATM and TATM. So by a characteristic gas equation, I know I can find out VATM. So this is my first target, VATM. So I know VATM. So I measured here V in volume flow rate. What is this? in meter cube per second, and this V atmospheric is in specific volume meter cube per kg. So I will get here meter cube per kg. So by multiplying this, I will get here kg per second mass flow rate, mass of air kg per second. So now here, the air, this is a atmospheric state. So now this is number one state. I will get here P1 and T1. So I know pressure, I know temperature. I can find out a V1 no need now once I know mass flow rate. Now this air goes in a compressor where the pressure is increased to P2 and T2 and V2 specific volume. So this compressor is run by the electric motor. Here is the electric motor. This electric motor is running at n RPM with a torque T. This electric motor is run by a electric WEL, electric current. So electric current is a input and we will get the output as W motor. So what is the W motor? So this is the diagram. Now I will explain one by one. So we'll calculate first nine steps. The specific volume. So first my target. Specific volume of atmospheric air. How I can find PV is equal to RT. So I can use this for atmospheric, and atmospheric. So R is given, everything is given. So I can find out V atmospheric is equal to RT atmospheric by P atmospheric, PATM. So R is, as is given, I wrote before, 0.287 kilojoules per kg Kelvin. So here kilojoules is not allowed, only kilo, 0.287 10 to the power 3 joules per kg Kelvin. Then temperature should be in Kelvin, 297 Kelvin divided by pressure 1.01135 into 10 to the power 5 Newton per meter square. So this Kelvin and this Kelvin is get cancelled. Joules means nothing but Newton meter. So this Newton and this Newton, it gets cancelled. So this meter cube is under denominator. It will go up. It will become meter cube per kg. So this is meter cube per kg. If you play with unit, there is no chance of mistake. You will find your mistakes. So write the unit also. Better practice. So you will get the answer here, 0.841243.5. No need. Then now I will go to the point number 1. I know to find P1, T1, and I need to find volume flow rate, air flow rate. Again, I will find the V1 volume here, P1, T1, and V1. So how I can find V1? So I can write here specific volume of air at the inlet of compressor. 1 point inlet. So P1 V1 is equal to P2 V2 or is equal to PAV. So what is my target? First I need to find V1. So I can write from this here, V1 is equal to specific volume, V1 is equal to, so I will make a specific by small v. Okay, V1 is equal to PAVA by P1. Okay, so I know all these values. Put all these values. So P1 is 1.01325 into 10 to the power 5 will get cancelled. VA atmospheric is, here I wrote 0.841235 divided by P1 is 0.86325 into 10 to the power 5. So this will get cancelled and V1 is equal to 0.98741 meter cube per kg. Now my target is to find out mass flow rate of air. What is the formula? I don't know. But what I need in kg per second. So this is kg is a mass, per second means rate, mass flow rate, kg per second. Okay, so I need kg. So this I have meter cube per kg. Okay, and I have V in meter cube per second. So what can I do with that so that I will get kg per second? So here I can do, I know continuity equation. So I'm trying to find the formula rho A C. C is called velocity. So velocity, what is rho is called density, kg per meter cube. density of air. What is area? Meter square. What is velocity? Meter per second. Meter square into meter per second. What is this? Meter cube. Kg per meter cube and meter cube per second. So what is this meter cube per second? Volume. V in. I can write rho into V in. Volume flow rate. What is density of air? I don't know. What is density of air? I don't know. Kg per meter cube. Okay, if I write meter cube per kg, what is this? Specific volume, V1. Okay, so when I make a reciprocal of specific volume, I will get density. Or if I make a reciprocal of density, I will get specific volume. So this is nothing but 1 by V. So I V in by V1, specific volume. Volume flow rate by V in, I can find out the mass flow rate. So what is V in? I calculated before 5.5 into 10 to the power minus 3 meter cube per second. And what is V1? V1 just I calculated here 0.98741 meter cube per kg. See this meter cube get cancelled and this get cancelled, kg per second. 5.5701 into 10 to the power minus 3 kg per second. So this first objective is finished. Now we'll go to the second part, energy. This is a electric motor and this is a electric cable. So what is coming in? WEL. Okay, is going out from this a W motor. So number 12, a mechanical power developed by motor, electric motor. So W motor I can find 2 pi nt divided by 60, where this is RPM, okay, or 2 pi omega t RPS. So here I need a torque. So how I can find torque? Torque on the motor is equal to T is equal to force into the length of R given to you in the observation table. So force I found 10.979 and the length of arm is 0.2. So here force is 10.791 Newton into length of arm is 0.2 meter. So here I will get 2.1582 Newton meter. It is called joules. Okay, Newton meter. This is torque. Now once I know torque, I can find out. So W motor is equal to 2 pi omega en or RPM 27 RPS. I am putting RPS 27.663333. Torque is 2.1582. So this is revolution per second, and this is Newton meter. So I will get Newton meter per second. Newton meter per second is nothing but joules per second is nothing but watt. Okay, so what is the answer? 374.718 I know input, I know output. So by first law of thermodynamics I can find out a delta E. So this delta E is nothing but it will become a hot electric motor, will become hot, it will reject the heat to atmosphere, and that is Q motor. So by applying first law of thermodynamics I can find out emitted by electric motor is equal to Q motor. So how I can find the first law? What is the first law? By first law of thermodynamics, this is a system, this is in. What is in here? WEL. Out, W motor. And what is the, because it becomes hot means Q motor. So I can write the formula from here. Energy in is equal to energy out. So what is in here? WEL. What is out? To out, W motor plus Q motor. So what I need? Q motor. No need to memorize any formula. Okay, so I can write here Q motor is equal to WEL. How much WEL? So 920 minus 374.7183. So here I will get Q motor is equal to 554.2817 watts. Now come to the compressor. This is state 1 and this is state 2. So what is the pressure here? P1, V1 and T1. What is the pressure here? P2, V2 and T2. This is run by the electric motor, W motor. Now this compressor will become hot again. Q compressor will go out. Low pressure here is converted to high pressure. Means some energy is added in the year, and that is given by the energy added, and this is another output that is called the useful output, W com. Means work done by the com, energy added by the compressor, or we can say work done by compressor here by compressor. The meaning is same. What is this? MCP delta T, the basic formula, energy added. So MCP, mass of here, specific heat of here, and delta T is nothing but T2 minus T1. So I know M 5.5701 into 10 to the power minus 3. Specific heat, it is given in the observation 1.005 into 10 to the power 3 because joules. And T2, here you can put a degree centigrade or Kelvin, doesn't matter. T2 is 335 as we recorded here. We didn't wrote, so we can wrote here also T2. So T2 is equal to T2 plus 273, you will get Kelvin, 335 Kelvin. So take this temperature, 335 minus 297. See the unit now here. Play with unit, you will find the mistake if is there any. Mass flow rate, kilogram per second. Specific heat, joules. Joules means Newton meter. Joules per kg Kelvin, and this is Kelvin or degree centigrade. Here Kelvin get cancelled, kg get cancelled. Newton meter means joules per second, and it is nothing but watt. Work done by the year, energy added, it is 212.72111 joules per. To apply the first law of thermodynamics again here, energy in is equal to energy out. So what is energy in here? Energy in is W motor. What is out? The work done by the compressor plus the energy Q com. Number 16, energy emitted by compressor Q com is equal to W motor minus W motor is in minus W com is a useful work, 374.7183 minus W com is 207.2111. So I will get this answer. Energy emitted by compressor 161.997 watts. Now what is the total heat emitted? 17. I calculate total heat emitted. Total is equal to from compressor and from electric motor. No need to memorize. Okay. So this is not formula, this is logic. Q compressor is 161.997 plus Q motor 554.28176. So here I will get 707.2789 watts. Now all input and output energy I calculated. Now we'll come to the efficiency section. So first I will find the efficiency of the motor is input by output always. Efficiency motor, W motor. What is input? Electric current, WEL. So this is not memorized. The diagram is in my mind. 374.718239 divided by WEL 290. So what get cancelled? Yeah, before multiplying 100, I will convert. So this I will get 0.4073. I can write 40.73% by multiplying 100. Now next efficiency 19. Efficiency of this is called mechanical efficiency. The compressor have a lot of efficiencies. I will explain here now. So first efficiency input by output, I will calculate that. N compressor is equal to what is the output of the compressor? Work done by the compressor. What is input? W motor. So W compressor is 212.7211. W motor I calculated just now. W motor is this 374.7829. So I will get a fraction. The compressor efficiency is 0.567682. Or it is nothing but 56.4 0.768%. So this is the first efficiency of the compressor. There are two efficiencies of the compressor. One efficiency is related with the size and one efficiency is related with the temperature, because the temperature is my output and size, the mass flow rate, is volume flow rate is also my output. So there are two efficiencies. First efficiency is called isentropic efficiency. What is meant by isentropic efficiency? Listen carefully. So I will draw the PV diagram. Why I draw PV diagram and TS diagram, I will explain here. So what is the significance of the PV diagram? So atmospheric air at state 1 is compressed to, okay. Then there are three types of compression process. If I say the air is compressed isothermally, another type of compressor is air is compressed polytropically, and one more, the air is compressed isentropically. So there are three processes. So first process is PV raised to gamma is constant, is called isentropic process. Second, PV raised to n is equal to constant is called polytropic process. And third process is PV is equal to constant is called isothermal process. So here T1 and T2 is not constant. So here I can say this is not isentropic isothermal process. The isentropic process means 1 to 2, means here the area under this curve is 0. TS diagram is drawn to draw the area under curve and we will get Q. This PV diagram is drawn to find out area under the curve 1 to 2 is called work, and here polytropically will be shown like I will make the green color. So this is a polytropic or actual process. So this is a pressure line. I will make the pressure line. So here pressure is, so here P2 and here P1. So point 2 will be, so this is actual compression, and this is a 1 to 2 is a, so this is a straight line, vertical line is a isentropic process, and this is denoted by 2s. The actual is 2. So the see the temperature T2 and T2 is greater than T2s because the air heat is added in the air, so temperature will be increased. And if the heat is 0, so we'll get this 2s. Okay, so it is a lower if Q is 0. So this is a irreversibility associated with the compressor, and here the actual temperature rise and theoretical temperature rise, that ratio is called the isentropic efficiency. So isentropic efficiency of the compressor is defined as isentropic is equal to, so it is related with temperature. The actual temperature is 2, and what is the theoretical temperature? 2s. Which is more? T2 is more. So T2 should be down. T2 minus T1. Actual rise in temperature with a theoretical rise in temperature, T2s minus T1. So here I know T1, here I know T2, here I know T2, I don't know T2s. How I can find the T2s? By the isentropic equations. What are the isentropic equations? Ideal gas equations. T2 by T1 is equal to P2 by P1 raised to gamma minus 1 by gamma, n minus 1 by n for polytropic, gamma minus gamma. So here if I write gamma, then this should be applicable only for isentropic process. So from this formula, I can find out isentropic temperature of air at outlet, that is T2s. How I can find T2s equal to T1, T2 by P1 raised to gamma minus 1 by gamma. What is gamma? I explained already. Cp by Cv. If it is not given, Cp is 1.005 divided by 0.716. So I will get it 1.4. If there is a mistake here, I always confuse 786 or 716. So it doesn't matter. I can write the answer 1.4. Okay. So this value is I know. You can memorize this value forever, or otherwise you can do by this method. As I told you, if you know two values, Cp minus Cv is equal to R. Any two values, we can find all rest. Okay. So here the temperature should be in Kelvin, and it is very important, 297 P2 is, it should be absolute pressure and not a gauge pressure. So P2 is 1.31325 into 10 to the power 5, and P1 is 0.86325 into 10 to the power 5. Gamma is 1.4 minus 1 divided by 1.4. This is multiplied. So I will get the answer T2S is equal to 334.8241 Kelvin. Must be in Kelvin. Okay. So once I know, I can find out isentropic efficiency. N isentropic is equal to, so I will get 0.9953. Okay. It is nothing but 99.53%. No worries. The isentropic efficiency of the compressor is always 90 to 98%, and turbine isentropic efficiency of turbine is always 80 to 90 or 95%. So this is a theoretically, keep it in mind. So no worries for your answer 99. Now there is another efficiency of the compressor, and that is called volumetric efficiency of the compressor, 22. So 22, and it is defined as the actual air go inside and what is the maximum possible air can go inside. It's the size of the compressor. Volume flow rate, actual air in divided by maximum possible air in, and that is a capacity of compressor. So what is the actual air go inside the compressor? The volume flow rate V in, and what is the capacity? V swept volume, stroke volume, swept volume, stroke volume for reciprocating compressor, swept volume for rotary compressor. So check the unit now. What is the unit given to you? V in is in, I calculated already, meter cube per second. This should be in meter cube per second, should be. But what is given to me? 267 centimeter cube per revolution. So see, units are not same. So I need to convert V swept is equal to 267 centimeter cube per revolution. What I need? Meter cube per second. So I have to multiply by revolution. 267 centimeter cube per revolution. Then if I multiply by N revolution per second, not divide. Okay. So 267 into, I will replace this meter, centimeter. So what is centimeter? 1 centimeter is equal to 10 to the power minus 2 meter, or 100 centimeter is equal to 1 meter, 1 meter. I know that. So I will replace centimeter, 10 to the power minus 2 meter, and cube as it is, revolution as it is. Now I will multiply by N. What is N? Omega. Yes, here I wrote 27.6666, 27.66334 revolution per second. Now this revolution get cancelled and I will get meter cube per second, which swept volume as 7.3281 into 10 to the power minus 3 meter cube per second. So as I know swept volume, I can find out the efficiency as, so now I will put the values. What is V in? V in 5.5 into 10 to the power minus 3 and 7.3281 into 10 to the power minus 3. So unit are same now, meter cube per second and meter cube per second. So this will get cancelled and I will get the volumetric efficiency is 0.7454 is nothing but 74.54%. And now last calculation, 24 overall efficiency of thermodynamic system is nothing but N overall is equal to, you can write the input and output. So output is W com, work done by compressor on air, and input is WEL. Or it is given by efficiency of all motor multiply by compressor multiply by isentropic multiply by volumetric. So all efficiencies are multiplied together, and here we need to take the fraction all fraction, this fraction. The efficiency of electric motor is 0.4073. Compressor efficiency of compressor is 0.567683. Isentropy efficiency is 0.9953 and volumetric efficiency is 0.7454. So overall efficiency is 0.17156. So I can write 17.16%. So this is overall efficiency of the system. Hence we finish the calculation. Transfer all these values in the table in this format. Yes. Condition of here, enter these values unit with unit and transfer all the value in this format table. And this finish the experiment, sample calculation, and now there is no graph because we did calculation only for one calculation and no need one reading, no need to do for other, just only do for one and write the conclusion what you learned from this experiment. Thank you very much.